Hi, my name is Ananela Ramirez, and this is my final key activity for Energy and Transformation 2. The justification of my project is to identify the change in the scales reading when introducing an object hanging from a cord into a container filled with water without it reaching the bottom. And it's meant to prove theoretically and experimentally that the weight will increase because of additional forces, and therefore the scales reading will increase too. The theoretical framework is we need to know that the weight of an object is measured in newtons according to the SI, and the mass of an object is the amount of matter it has, and its SI unit is a kilogram. Also, we need to know that scales measure the force the object exerts in them, meaning their weight. Then the scale divides the obtained weight by the gravity because of the formula weight equals mass times gravity, and shows as an output the object's mass. So the methodology for this experiment includes the variables, which are the dependent, the final mass measured by the scale, and the control variables, the mass of the water and of the different marbles. And the method was to place a container filled with half a kilogram of water on a digital scale, tie a marble to a cord, holding the cord, introducing the marble into the water without letting it touch the bottom of the container, to annotate the scales reading, and finally to repeat the process with the different marbles. The materials I used were a digital scale, a water container, water, a cord, and different sized marbles. One of them had to be replaced with a lemon because of a lack of marbles. And they are all illustrated in the picture of your right. So these were my results. They're explained in a chart which have the number of marble, the mass of the marble, and the scale reading after introducing it with a cord. And on the bottom, we can see the graph, which compares the marble's mass, the scales result, and a trend line, which is dotted there. The analysis of the results are: before the marbles were inserted into the water, the scales reading was based only on the water's force in it. Then when introducing the marble tied to a string, the marble experiments a push equivalent to the volume of water it's displacing. The total force read by the scale will be the sum of the water force, which is 4.905 newtons, plus the force of the displaced water. Remembering the force is equal to the mass times the gravity. Then to calculate the water displaced, we need to calculate the volume of each marble. Marble 1 has a diameter of 17 millimeters, marble 2 of 25 millimeters, and the lemon of 3 centimeters. The volume of a sphere is calculated with 4 times the cubic radius. So we get the final scale reading with the sum of the forces by the gravity. Then here's another part of the analysis where we have the theoretical results with each marble, the mass of the marble, the water it displaces, its total force, and what the scale reading should be in grams. And at the bottom, we have a comparison with the experimental results in blue and the theoretical results in orange. As you might see, they're a little bit different, but I can conclude that this difference could be due to the inaccuracy of the digital scale in the experiment, along with inaccuracy of the calculations made in the theoretical way due to the decimals that are lost. And well, since the values used were really small changes in the decimals can turn out in significant changes on the final results. The noticeable difference between the marbles and the lemon on the experimental way might be caused by the density of the lemon. Since the lemon kind of floats in the water, the final mass read by the scale was the same as if it was placed in the bottom of the container, because the full force of the lemon is being applied over the water, contrary to the marbles, which just the force was the one that displaced the water. And well, what was stated in the introduction was accurate. When a non-floating object is introduced in water without it touching the bottom of the container, the scale or reading changes because of the force the object exerts on the water and not because of it touching directly the base of the scale. And in order for the experiment to turn out as the theoretical results, a very accurate scale is needed. Otherwise, fluctuations like the one in my own experiment will occur. Here are my references, and thank you for your attention.